Welcome. So if you like math videos, this is definitely a good channel for you. Here's a question. The limit as x approaches 3 from the right of ln of x squared minus 9. Can you find the limit? So I'm going to leave this on the screen for a count of, say, 5 and let you try. Okay, elevator music is over. So let's answer it together. Let's take a look. So I'm going to say the following here. I'm going to define t to be rather equal to x squared minus 9. Let's stop for a second. Why am I doing this? Because what it allows me to do is use variable substitution. So t is equal to x squared minus 9. Now take a look at this. For example, when x has a value that's very close to 3, but to the right of the 3, so for example, imagine x has the value 3.001. That's very close to 3, but to the right of 3. That tells us the following, that t would be equal to 3.001 squared minus 9, because that's the definition of t. I'm going to give you some numerical background before we get to the more abstract stuff, so it makes more sense, okay? So let me work this out on my software here. So I've got 3.001 squared. So that's, if you look down below here, it's 0.006001. The actual value itself is not important, right? What matters is that when you look at this value, it's about this, 0.006. Let's do one more. You want to be able to see a pattern. Imagine it's 3.0001 now. Okay, what does that mean about the value of t? So t would be 3.0001 squared and then minus 9. If I work that value out down below, let's take a look at that very carefully. It's going to give 3 zeros and a 6. So it's about the same thing as above, just with one more 0. So it's 0.0006. So notice the pattern. Here you see x is getting closer to 3. It's 3.001, 3.0001. Each of those values is getting close to 3 from the right of 3. That tells you the resulting effect on the t is that it's 0.006, 0.0006. Each of those values is close to 0, but still to the right of 0. You see that? You want to be able to see that pattern. Really important. So the next step, what this allows me to do essentially is write that it's going to be like this. The limit now, as t approaches 0 from the right of ln of t. That's why I had to do this bit of numerical work so it would make more sense. If I have a feeling, because I've done this before, if I just wrote ln of t as t approaches 0 from the right, that may not be very obvious. So the fact that it says t is approaching 0 from the right, that's coming from this right here, right? 0.006, 0.0006. Each of those values is a value of t and it's approaching 0 from the right. That's why I can rewrite my limit this way. And instead of having x squared minus 9, I can have t. But now this is a well-known fact. This is based on a basic ln function. So in case you don't remember, the basic ln function, if I were to graph it quickly, it kind of looks like this. Okay, let me throw in a coordinate system here and do a bit of graphing for you, just to remind you. Okay, so imagine we have this coordinate system here. Okay, basic concept is the ln function. Let's see, this is a really rough sketch, looks like this. So if you look at this function, you see the following essentially is true. Okay, you're going to approach 0 from the right. That's this way. The result, and I'm going to emphasize that graphically, so it's very clear hopefully, is that the outputs go down towards negative infinity, which is what the green arrow indicates essentially. Okay, so it's going to tell me that over here, the output will look like the following, negative infinity. That's the value of the limit. So if you like math videos like this one, please give a like and subscribe. Remember, to get good at math, you just have to practice a lot. That's all it is. It's like anything else. If you do it enough, you can build a lot of intuition for it, and it doesn't have to seem mysterious anymore. That's what I've learned. I didn't have much talent for it, but the only thing I had going was I found it very interesting for some strange reason, and then I just, practiced a lot. Eventually, the pieces snapped together. Thank you so much. I'll see you in another video. Leave a like and subscribe.